Welcome to Hidden Layers AI. This is Guru. As part of this channel, I cover the topics from Python, OpenCV, machine learning and deep learning. I try to upload videos once in a week. Please subscribe to my channel, The Hidden Layers AI. Today we are going to cover how to smoothen and sharpen the images using OpenCV. Here is a very important concept that we are going to cover. It's called kernel. So idea behind it, you have one image and you want this image has some kind of noise, and this noise generally comes when we acquire this either images or in the form of signals where instrument continues to give some kind of noise, and we would like to see how we can remove those noise. And this particular removal of noise is called blurring or smoothing. For that we generally use a concept called convolution using some kind of kernels. So let me explain a bit of kernel. First, you have an image on the left. This is the source image. Imagine yourself as a painter and it is a wet paint. In that case, what we would like to do is, if there are some dust things are there, we would like to identify a nearby area and then mix those areas with either or oil paint to mix it and make it more smoother. So kernel is an equivalent of a brush here. We take this particular kernel and put it on the first pixel. When you put it on the first pixel, what happens is the top row and the left row of this kernel will be outside this image. But imagine yourself there is a padding of zeros around this image. So once you have that one, what we do is some kind of function between the values which is there on this matrix, which is on the kernel, and the corresponding points on the image. One can actually visualize it. You can have a weighted average of the kernel pixels with an image. For example, all the weightages and corresponding points are calculated, and then you get a weighted average of the kernels as well as the images. And once you get that, what we do is we keep that particular point wherever the center point is there and the corresponding center point on the image, the newly calculated value is being put. Depending upon the filters type or the kernel type, we have various types of blurring and smoothing. For example, one can have weights like 1, 1, 1, 1 like that within the 3 by 3 matrix, and it is divided by 9 because if you multiply this weightages with that image and it becomes more. So to normalize it, we would like to divide by the number 9 so that it is the after multiplication it becomes 1. So this is particular thing is called uniform blurring. Basically, in the imagination of mixing the colors, we are basically taking every color from each of the sides and mixing together and resulting the new point. Other way of mixing is, or other kind of brush or other kind of kernel is Gaussian kernel. So this kernel is different from this blurring in terms of its how the weight distribution is there. If you observe this weights, you have a center very top, and then you have a twos around like circle, and then there are ones. You can imagine yourself is like some kind of normal distribution of these numbers, and that is why it is also called Gaussian kernel. Third blurring and smoothing technique is a median blurring. In this case, we don't multiply the weightages with the corresponding images. Rather, we pick up all the points and sort them in an ascending order and plot them in a graph or distribution graph, and then pick up the middle one, which is nothing but picking up the median value of the points which are under the kernel, and you pick up that point and use that as a the resultant point in the destination. So that is why it is called median blur. Fourth one in this series of blurring smoothing techniques is bilateral blurring. Here we need to understand there are two functions are there. One is space, across space and across the colors. Say if you observe this one, you can also assume that it is a space in the sense that from center it is going away like this, right? So in this case almost like one radius is, at the middle it is the center, and the same thing it is radius 1 pixel, you can assume it, but it is square, not a circle. So what it means is when the kernels increases, you would continue to increase the size, and it will follow the models that we have. So that means we can take a decision how far those pixels are there and how much we are giving a weightage to that. So that particular piece is already there in the bilateral. It is similar to Gaussian Blue. Then apart from that, we also have a weightage given to the intensity of the pixels. The pixels around that middle, we have to find out the difference between the intensity for each of the pixels in the kernel and see which is the most nearest to the center of the curve. So in that way we pick up that and we do an average of it and weighted averages and then pick up that. That means it has got the weightage is decided, or the new pixel is decided not only based on the distance of the corners, at the same time the intensity differences also considered. So it replaces the intensity of each pixel with the weighted average of intensity value from the nearby pixels. Sharp edges are preserved and while discarding the weak ones. Now that we have seen all these kernels in the positive numbers, but we can also see some kind of negative numbers and apply the same concept. In this case, we will take a new kernel where all the numbers are negative across all the borders, but whereas the center one is and positive. So if you sum it all of them, it becomes a 1. So it is already standardized kernel. So we don't need to really divide it by any number. So what it does is when you convolute this kernel over the image, on the particular pixel, the existing pixel is multiplied by 9 times. That means it is highlighted by 9 times, whereas then around that numbers are also decreased by 1%. And because of this, the center pixel it becomes more closer to white. The observation that you find it, the edges are sharp, at the same time it is highlighted with more white, which is nothing but sharpening. For that we have a generic function called filter today, which we will apply. In this session we have covered the concepts. In the next section we will use and show in the code same concepts. If you are still here, I would like to request you to subscribe to my channel, and thank you very much.